Good morning or good afternoon, chemistry students, depending upon when you're watching this. I just want to kind of go through, so we're skipping back to chapter 4. First of all, I apologize. I got a little throat thing going on here, so I sound a little, I don't know, Darth Vader-ish maybe this morning. Um, anyway, we're going to go back to chapter 4, which kind of talks about the discovery of those subatomic particles. Um, So we're going to talk about a couple of really important people in the development of atomic theory. So of course we've talked about atoms and what an atom is, and the atom. Some of the larger atoms can actually be seen with the scanning electron microscope, but we could never see those subatomic particles. So how do we really know that they're there and what their charges are? Like, how do we know all this stuff on something that we really can't see? And in science, of course, we're always looking at what evidence there is of certain things. We don't just blindly believe because someone said so. We check stuff out and we look at the evidence. So the the early models of the atom. So first of all, atom, that smallest unit of an element that retains the identity of an element. So I can have a sample of gold, and the smallest sample of gold I can have is one atom. Because if I actually split it into some unit smaller than that, it's not gold anymore because it doesn't have the right number of protons. So atomic theory actually goes way back to the Greeks. Democritus in 460 to 370 BC was the first person to say, hey, we think all the stuff in the world is made of these tiny little indivisible and indestructible things, and he's called them atoms. But he really didn't have any proof. He just kind of had this sort of guess that they existed. And as it turned out, he didn't really understand. He thought there were four types of atoms. So Democritus thought that there was earth, air, fire, and water, and that those were really the four types of atoms that made up all the things in our world and in the universe. So he thought people were a mixture of of a certain mixture of those four, and everything in the world was a different mixture of those basic four types of atoms. So of course Democritus lacked that proof. And remember, this is, a very, very long time ago and way before we had any modern instruments. And so when we're looking at, you know, the years that Democritus came up with that theory, of course, how could he possibly know anything? And it wasn't until much, much later that a really smart man named Dalton came up with a kind of more modern atomic theory. So this is Dalton, 1766 to 1844. He developed the theory based on things that other scientists had sort of developed, and he kind of summarized these into four basic steps. So of course I want you to jot these down. All elements are composed of tiny indivisible particles called atoms. And of course, by this time there was some proof, obviously. Atoms of the same element are identical. So if I have an atom of carbon, um, all the carbon 12 atoms are the same. There's and he also said the atoms of any one element are different from those of another element. So he's saying the structure of a carbon atom is different than the structure of an oxygen atom, which is different than the structure of a gold atom. And that structure is what gives them different properties. Atoms of different elements can physically mix together. So, or they can chemically combine in simple whole number ratios to form compounds. What this means is there's sometimes we just mix things together and they don't chemically combine. So I can mix together some iron and some silver, and they might not chemically combine and fuse together. It's just a mixture of those two substances. But sometimes when we mix things together, like oxygen and hydrogen, they bond together in whole number ratios, because we don't have half atoms in formulas, in whole number ratios to form compounds. And then his fourth postulate was chemical reactions occur when atoms are separated from each other or joined, or they're rearranged in a different combination. So that means that atoms either separate in a chemical reaction, so we can break things apart. We can actually take water and break it apart into hydrogen and oxygen, or we can take hydrogen and oxygen and they bond together to form water. And sometimes we just have different ratios of elements that are composed of the same thing. So some examples of sometimes atoms are just rearranged. So we can have carbon oxygen compound that is carbon monoxide, or we can have carbon oxygen compound that's carbon dioxide using the same, if we had a large sample of carbon monoxide, those could rearrange. And the same thing with H2O or H2O2. Um, so So these obviously have different properties. The one thing that Dalton said, though, atoms of one element, however, are never changed into atoms of another element as a result of a chemical reaction. And we would say this is mostly true, but there are exceptions to this we know now. And he didn't know this at the time, but we know now that there are some exceptions to this part. So, for example, in nuclear reactions, we actually are changing one atom into another type of atom by either splitting atoms or by fusing atoms together. So that's actually what's happening in nuclear power plants, that we are actually changing, one type of atom into another type of atom. So do a little research of that process, and kind of check that out. But so now we kind of say this is true in ordinary chemical reactions, but obviously there are those nuclear reactions. So that's kind of it for the first part of this chapter. So at this point, once you have the notes down, and I'll post them too, just work through that first worksheet. And we'll talk to you tomorrow.